So depending on the client that you're using depends on the format of the content that gets shipped back, is what I'm getting at here. So when you're looking at this is XML. Another common format is a JSON format. If you aren't familiar with it, or if you want to know more about it, the site still exists, you can go to json.org. It's a very bland website that tells you all about JSON. It actually has some interesting reading if you want to get into the mechanics of it, but outside of that, I do not spend my time at json.org. So, what does this JSON request look like? Well, I think I have the tool on here. I do not. No, I am not wondering what's new, Windows. If you're doing any kind of web development, I'd recommend going out and downloading a tool called Fiddler. I don't have it on this machine, so I'm going to go out and download it. It's a free tool. I want version 4.
We download it right now, or
if you're on your own computer, you're welcome to do it. If not, you can go back and find it later. How do I plan to use Fiddler for debugging? Do not keep me informed. Alright, so it's going to download. It's a real quick little app. And frankly, it's kind of fun to use even if you're not doing development. So what Fiddler does is Fiddler hooks into your operating system and acts as a pass-through proxy for all of your HTTP traffic. Okay, what does that mean? That means that if you open up your browser and you type in a website address and you hit enter, when you hit enter, instead of your browser going straight to that server, it actually sends the request to Fiddler, and then Fiddler passes it to the server, and then the server responds back to Fiddler, and then Fiddler passes it back to your browser. Well, that sounds stupid, right? So what's the point? The point is, let's see if it launches on its own. Nope. Yes. Sure. Sure. I said yes to all of that if you're wondering. I'm going to do my WinConfig. So what I have to do for Windows 8 and above is you actually have to enable, you have to actually enable it so that Fiddler will packet capture because of security things. Alright. So if I go to apple.com, let's say. Don't want that. I do want this. Fiddler is capturing all the traffic between my computer and Apple. Every image request, every style sheet download, every JavaScript, everything. It's catching it both ways. It's capturing the request, what I'm sending, and the response, what I'm getting back. So it gives you performance metrics. The part that's most interesting is the inspector. So what you're looking at here is the HTTP request header, same thing that we saw in Chrome. But it's kind of broken out into a slightly nicer format, and then this is the response. We can look at this in a raw format or a kind of a readable format. Raw format's just literally text. This block of text, when your browser opens up a connection to a server and it actually goes to make that established connection to get the web page, this is literally what it sends. It basically knocks on the door, the server opens up, and then it goes whack and spits all of that text at the server. But it tells it, I want to get, which is that HTTP method we were talking about, http://apple.com in the HTTP 1.1 format. The host I'm attempting to connect to is www.apple.com. The connection it wants to keep alive so that it has constant communication. It will accept those different formats. I'm not sure what the upgrade in secure requests is. Something with Chrome. The user agent is identifying itself. This is Chrome. saying this. It says I'm identifying myself as the Mozilla 5.0 browser running on Windows NT 10 under WoW 64, which basically means that it's running as a 64. It's running on a 64-bit operating system. The Apple WebKit 53736 is the core. Do you guys know that Chrome is actually built on top of Apple's WebKit browser?
I did.
You did? Yes, they're actually using the WebKit from Apple, which is what Safari is written on. That's what Chrome is also written on top of. So if you ever heard of Mozilla, which is Firefox, WebKit is the equivalent of Mozilla, but it's Apple. So Chrome or Google uses Apple stuff. Anyway, it's like Gecko, Gecko being the Mozilla framework. And then it says, oh yeah, by the way, I'm Chrome 46. And then there's that Safari reference again for the Apple WebKit. So that's fine. All right, so there's all that jazz in there. So that's how, if you ever go to those websites, it goes, hey, you're using this browser. Hey, it looks like you need this download. They're doing that through this user agent. Except encoding, most web servers today will actually take all the content and use gzip or deflate to compress the content so it's not sending all the bytes. You know how you zip a file and it gets smaller, using the same technology to ship smaller packets of data between the server and the client. So your browser literally is doing unzips for all the content that it receives. Language, accepted languages, that's useful if you ever, well, you may or may not know this, if you ever travel outside the United States and you use a computer that's configured for a different country, when you go to Google, Google will automatically redirect you to the version of Google that's country specific. Sometimes it's translated into that language. It's done based on that accepted language. Header. Second from the bottom. And then this cookie, apparently Apple stuck it on my computer at some point in the past. So it shipped the cookie along. So all of this gets sent to Apple's server. Apple's server then responds with this HTTP file, which is here. Talks about caching and all this other stuff. Not really relevant, but you can come in here and look at it. So that's the HTML document. So then that process, again, just to kind of review, is the browser parses that HTML, finds all the image tags, style sheet references, script references, whatever's on the page that's an external resource, and then makes subsequent requests for that content. That being everything from this point down is all of that content. Yes?
So your browser goes there, and then it gets like a list of stuff it needs to get in order to like show that web page.
Yes.
Can we see like the thing that the server sends back says you need to get all this stuff?
It is. It's this. It's the HTML. So the browser literally takes that HTML response, and it looks for all the image tags, all the link tags, all the script tags, finds them and bundles them into requests. So if let's see, can I do that in here? There used to be, what's the hex? It may not exist. Yeah, I don't think it's in here. But yeah, that's basically what the browser does. That's the primary function of the browser, is to take this text and parse it, and then make all those requests. So it looks at this href and says, okay, I need to download that, I need to download that, I need to download that. Same with the images. It's all based on the HTML that you sent. So it goes through and does all those downloads. So why am I telling you all this? The reason is because these mechanics that your browser does is the mechanics that you're going to have to start to replicate when you're interacting with a web service. This is the way you have to think about interacting with a web service and working with that content. This is the methodology that you have to ingrain as you're doing that work. Without understanding at least how this works for a web page, it really becomes hard to interact and talk to a web service. And specifically, you have to understand how you're making the request so that you get the right response. So that, again, that first word up in the top of that header, is the most important piece when it comes to interacting with these REST-based services, because that method determines the rest of the response, or how that response is interpreted. The next most important thing is, what types of content do you accept? Okay? So I'm going to whack all that, close this, close this. I'm now going to refresh this and re-request. So we've seen this shouldn't be new. I'm making a GET call back to localhost, API, user registration, session ID equals 1. We saw all of this in Chrome. The host, the connection, that accept. There's some gzip encoding and all of those things happening. This is then that XML response that we get back from our web API server. So what I'm going to do now is I'm going to take this and I'm going to move it into another piece of Fiddler called the composer. I'll just do it this way. All right. So I drug that transaction, that request. I went to the composer tab and drug it in here, and it basically regenerated the request. Okay. So what I can now do with the composer is I can manipulate the header, which ideally will then adjust the response that I get back from the server. So the piece that I want to change is this accept line. I want to change it from all of that to simply be application/JSON. And I'm actually going to drop all of this. So just those 2 lines. There's nothing wrong with having everything else, but it's not necessary. And I'm going to go ahead and hit execute. So what's going to happen here, get rid of those, is that Fiddler is going to send the request and get the response. There's no browser involved at this point. Now, if you're not familiar with HTTP response, you have different response codes, 200s, 404s, 302s, 500s. There's a range of 500s. There's a range of all of them, actually. But a 200 means good request, I understood what you're saying, here's a response. Here's a content-based response, I should say specifically. So it responded back and said, okay, here's the response. It's an HTTP 1.1. There's no caching. The content type, the type of content I'm sending you is an application JSON character set UTF-8 encoded. It expires in 1 second. The server is an IIS server. It's running ASP.NET version 4.0. I'm not sure what the source files thing is, but it's powered by ASP.NET, and then this is the date, time, and Greenwich Mean Time that it was responding with, and then the length of the content sent. So this is, again, the header. This next line is the content that it sent us. That's the 140 characters worth of text. This text is now in a JSON format. So if I go to the JSON tab, Fiddler will provide us with a graphical representation. So it basically took that JSON and converted it into first name, last name, username, first name, last name, username, showing us that there's 2 objects. There's an array of 2 objects in this response. The same 2 objects that we saw previously in XML. What does that look like as a raw response? It looks, well, like that line of text. So I'm going to bring this into Notepad++. It's not going to format it for me. I'm going to bring it into this instead. So JSONviewer.stack.hu is a nice little tool. And we can say format. That's what I wanted to do. So Let me zoom that in. So what your JSON looks like is it's JavaScript, but it's JavaScript object notation. So what gets returned back, first of all, is an array. So the square brackets designate an array. If you ever done inline instantiations or inline creations of objects in JavaScript, you always use the array as the brace, and then you can put objects in an array and kind of separate. So if you kind of we'll take this a piece at a time. So square bracket, and a comma. So we have two items inside of this array. Each one of these items or objects is designated by curly brackets. So here's the curly brackets for object 1, here's the curly brackets for object 2. Each object has three properties: username, first name, and last name. That's designated by the stuff on the left side of the colon. The colon then is the property value or key value delimiter. And then the value of username for object 1 is Gantoka, first name is Kevin, last name is Gantos. Object 2, username Kevin Gantos, first name is Kevin 2, last name is Gantos 2. So it's the same data represented in a different format. Now, a lot of tools, especially for the JSON, can be rather complex, and they provide you with visualizations for that. Now, this response is an overly simplified response. You want to see a slightly more complex response? Actually, it's a fairly more complex response. I think this is still up and working, so we'll see. Okay, may not be. So these two modules here are loading based on JSON data. So this was a web page fetching JSON data and then dynamically inserting it into the page. That JSON data comes into requests, which I probably can't show you because SSL is not enabled. So let me go Tools, Fiddler Options, HTTPS, Decrypt Traffic, 5,000 foot view. What this is doing is it's going to install its own SSL certificate into my key store so that it can then act as an HTTPS or SSL proxy, allowing my browser to accept the requests and responses from Fiddler. So Fiddler basically turns into my server and it's encrypting content. And then it's making encrypted requests to the server, the actual web server, getting it back, decrypting it, putting it in Fiddler, and then re-encrypting it and sending it back to my browser. So it's, again, acting as a middleman. So let me reload this page. All right. So let's see here. So these are the two calls that get that data. So what you've got here is this GET call to a web service. This is actually written in a different server technology, but it's the same concept. So application/JSON, it's making a request saying get observations based on this session ID, and then the response that comes back is just a JSON response. So let me come down here and grab all of those. Copy. And it's awfully noisy. But the idea here is, so we're fetching a lot of data here. We've got ID, parent ID, first name of the user, parent ref ID. We've got data about the parent, data about the students, all encrypted or encoded inside of this. Same idea here. So this is the course data, which you guys can see earlier, and I'll jump back there. But you'll see here, preschool language arts, preschool behavior, preschool social studies, preschool science, attendance, math, preschool PM, all of that with different teacher information, room information, all of that is packaged here as JSON. So think of it this way. On the server, this was an array of objects that represented all of this data. The data then gets serialized or converted from objects into a single JSON package or payload, and then gets shipped to me as text. I then can pick this up in my browser, convert it from JSON back into objects, and then what happens is that it then gets rendered into this grid on the right-hand side. Yes?
Does it pass the whole JSON as a string?
Yes. Yes. All that JSON gets passed as a string. And then it gets parsed by the browser once it comes from the server. Yeah. All your JSON, all your XML gets transferred as strings. So then my code parses that and then generates this nice looking grid on the right hand side, not a dumpable JSON.